Okay, so let's look at this one here. And here we have a secant function cubed. Okay, so there's no tangent function. So in this case, we're going to end up using integration by parts. Okay, so to see this, I'm going to split this up into secant x, secant squared x dx. Okay, and so if we split it up this way, because we can't deal with this, so if we split it up like this, we see that we've got this piece and this piece. Well, this piece I can take the derivative of. The derivative of this is secant tangent. But I can't take the derivative of this, but I can integrate this. Okay? Because the antiderivative of this is tangent. So I can use integration by parts and see what happens. So I'm going to make u equal to secant x, and my dv equal to secant squared x. Let me write that further over. And so now du is going to be equal to secant tangent x. And then v is going to equal tangent x. And so now let me put the formula for integration by parts. So it's going to be uv, so secant x times v, which is tangent x, minus the integral of tangent x times du, where is it? Which is tangent x, secant x, tangent x. So v du, right? So we got tangent x times secant x, tangent x. Okay. So now I'm going to rewrite this, right? So this gives us what? Tangent squared x secant x dx. Okay. There's nothing I can do with that. I mean, I can't do anything. So what I'm going to do is I'm going to replace this with secant, because I know the identity for this one, right? So let's make it in terms of secant. So let's write this as secant x tangent x minus the integral of secant squared x minus 1 times secant x dx. And so this will give us secant x tangent x minus the integral of secant cubed x minus secant x dx. And so I'm going to rewrite this as two integrals. So this is going to be secant x tangent x minus, well, actually I'm going to put plus, because this is going to be minus this plus this. Well, yeah, let me just do it this way. So secant cubed x plus the integral of secant, well, this is dx. Let me write this a little better. Okay, so now that's what I have, right? So now, this I can integrate, right? You should know the integral of this, okay? So we can integrate that. So this is going to be secant x, tangent x, plus, and so the integral of secant x is what? Right, that's that one of the ones you have to know. Okay? So remember, this is one of those ones that you can derive, but again, I wouldn't want to derive it. This is the one where you're going to get the natural log. So it's going to be the natural log of the absolute value of tangent x plus secant x. Tangent x plus secant x. Now minus the integral of secant cubed x dx. Okay, so look at that for a moment. Okay, so we've got everything, and we've got this integral, and we got the same integral that we got before. So, right here. So this is what we were evaluating. And so we did all this work, and we integrated this, we got that piece, and now it looks like we got the same thing. But remember, we've done this before, right? So that means I can add that to both sides. And so when I do that, what am I going to get? I'm going to get double this is equal to this. So let's rewrite that. Okay? So what you're going to do is when you add that to both sides, you're going to get 2 times the integral of secant cubed x dx is equal to secant x tangent x plus the natural log of the absolute value of secant x plus tangent x. Gosh, keep. Okay, like so. So far, so good, right? So now, guess what? All I have to do is divide by 2. So my end result is going to be what? Oops, not us. Is going to equal 1/2 secant x tangent x plus 1/2 the natural log of secant x plus tangent x plus c. And I'm done. Okay, here's one for you guys. I know you've been dying to do one. So here's one for you guys to work on. So try this one on your own and see what you get. So this is tangent cubed x secant to the 7th power of x dx. So you guys do this one and see what you come up with. Okay, is there another one? Let me see if there's another one that they want you guys to do. No, that's it. Okay, so next time we're going to start talking about reduction formulas. See you then.